So now let's look at some basic terminologies which we need to understand to go further in the cybersecurity world. First and foremost, network. What is a network? Network is nothing but a group of interconnected devices. Could be servers, could be workstations, could be laptops, could be any devices, file printers and whatnot to be interconnected with each other. As you can see in the diagram, it is used for communications. It's primarily used for data transmissions and to communicate between various terminals so that the business can go on. It is also used to share data and information. It could be wired or wireless. So you got a wired LAN, or at home, we all have wireless networks where we connect all our devices. We use them for streaming videos. We use them to connect to the internet, surf websites, work from home. So we got office also set up on our Wi-Fi. So a network is nothing but a collection of interconnected devices that are allowed to communicate each other freely so that the business can be continued in a proper manner. Server. The server is nothing but a hardware device that is supposed to handle requests of data information, allow network services to function from other computers and devices. So this is where we build a client-server relationship, where on the server we got the major software, we got the data that is stored over there, and clients then interact with the server to consume that data in a particular manner that would help them make sense and analyze that data and generate business out of them. Then the internet. Internet is nothing but the collection of multiple networks globally. So all the networks that we have across the globe, when they are interconnected with each other, that is what internet is. And if we just go back and we talk about servers, this is what allows the internet to be formed. So every organizations, when they publish their servers on the internet and they allow everyone to interconnect through those servers, that is where the internet comes in, the servers being the backbone of the internet. Obviously, for the servers to communicate with each other, we will need switches, routers, and other devices for the data transmissions to happen. So these are the multiple networks, could be individual networks, interconnected together would form the internet across the globe. For the internet to work, there would be a set of protocols for transmissions to be allowed across the globe. Now, this is where TCP/IP, or the Transmission Control Protocol over Internet Protocol, comes into the picture. So if you remember, we use communication channels like TCP, or the Transmission Control Protocol, and UDP, User Datagram Protocol. When we connect to web servers, we talk about the HTTP protocol and HTTPS protocol. If you want it secure, then we'll talk about IMAP, POP3, and all of these protocols. Now, where do these protocols come from? There's nothing but a suite of the TCP/IP software which contains all of these protocols which allow computers to communicate with each other. If TCP/IP wouldn't have been there, our network would have collapsed. Now, when we have TCP/IP and we want to communicate across the globe, how would we identify devices on the internet or even on the intranet? Because the devices don't know us. They are not going to use our usernames and passwords to communicate with each other. But when I want to connect to a website or a device, how do I identify it on the intranet or the internet? I obviously use IP addresses. Now, IP addresses are nothing but the internet protocol addresses, which are 32-bit addresses, which look exactly like the one shown on your screen, 172.16.254.1. Now, there is a lot of classification of IP addresses, and some of these IP addresses work on the internet. Some of them are supposed to work on private LANs, but we'll reserve that for a later topic. Then, the second way that we are identified on the internet or the intranet are with MAC addresses. So, media access controls or MAC addresses are hard-coded addresses that are given to our network interface cards. These cannot be modified physically at any point in time. However, there are techniques to spoof MAC addresses, which we can then obfuscate our existing address and give us a new one. That would again be discussed in a later lecture. A router. We've been talking about routers and switches. A router is nothing but a device that passes packets back and forth across networks. It routes the data in the appropriate path. So it is an intelligent device. It can understand IP addresses and MAC addresses. It can identify different paths of reaching a particular network. For example, if I'm sitting in India and I want to communicate across the world to America, there would be a specific path that needs to be followed for my data packet to reach the other side of the world. It is the routers that would map this path, store it in their cache. So when I try to connect to that server, they would retrieve it from the cache and send the packet across the globe. So the home router that we use at home on Wi-Fi is our default gateway to connect to the internet, and thus it allows our internal devices to communicate with each other using internal IP addresses. And when we want to go to the internet, it will then route the traffic on the internet and send the packet to other servers that we want to communicate with. Now, what is a domain? A domain is referred to as a group of computers and other devices that are interconnected and treated as a whole. Now, a domain is used by an organization. So let's say if I am XYZ being the name of the organization, and I want to create a domain which will allow me to create a group of interconnected computers for my employees to interconnect with each other and send and manage data. I'm going to create a domain for my organization and attach all the devices, create users, and interconnect them using a domain. So this is where you're going to have a centralized approach of a server-client relationship, where you're going to have a main domain and you're going to have devices connected to the domain. Now, when we go onto the internet, the domain name is nothing but the base part of a website name. So when you say google.com and you type it in your browser, you're taken to the web page called google.com, which is the search engine that you're connecting. But for Google, the organization, at the other end, they would have a data center over there which would have all that relevant data which allows you to search through that information. So for them, the domain would be the internal part where they've got this cluster of servers creating a data center where all that information is stored. But for us as consumers, a website called google.com would be a domain for us to visit that particular website and consume the services that they're offering on the internet. So here the example is HTTPS, which means that it is a secure website, port 443, and we're connecting to cybersecurity.com. Cybersecurity.com becomes the domain name. HTTPS becomes the protocol that we want to utilize to connect to that particular website. Then we come across DNS, or the domain name system. It is nothing but an index, something like a phone book, which is responsible for mapping the domain name into its corresponding IP address. Now remember, I said that there are only two ways we are identified on the internet or the intranet, either the IP address or the MAC address. If it is devices, but it is computers who are talking to each other, it would obviously be IP addresses. But if I type in google.com, I'm giving it a domain name. The internet does not understand domain names. So there's a DNS, a server, which is an index or works like an index or more like a phone book, which will have a list of all the domains with their corresponding IP addresses. So whenever I type in google.com, the request goes to a DNS server. The DNS server is queried. The IP address of google.com is identified, pasted onto the packet, and then the packet is routed through the router to the path that it has determined to reach the google.com server. Here, replace google.com with cybersecurity.com. So, as you can see on the screen, the local PC queries the DNS server. The DNS server replies back with the IP address. Now, if you're wondering how does this work, if we're going to take an example of home networks, the ISP or the internet service provider gives us a default gateway or a router with their own IP addresses for DNS servers and default gateways. So when we try to connect to the router has the IP address of the DNS server and it routes that query to the DNS server. The DNS server replies back with the appropriate IP address. The router then takes that IP address, figures out the path, and sends it across to the targeted server. DHCP, or the Dynamic Host Configuration Protocol. It is a protocol that dynamically assigns IP addresses to the devices in the network. So, we have discussed that IP addresses are required by computers to communicate within each other. But who associates or who gives these IP addresses to these computers? So for that to happen, we have got a DHCP server that is created. If you take your home networks, it is the router that has the DHCP role installed on it. So whenever a machine boots up, it sends out a broadcast request looking for the DHCP server, and then there's a communication with the DHCP server. The DHCP server then allocates an IP address to the computer who is requesting it. And once the IP address is allocated, an entry is made in the DHCP server's cache with the corresponding MAC address of that particular machine. And then we come to the next topic called VPN, or a virtual private network. It is a connection between a VPN server and a VPN client. It's basically an encrypted channel that you're creating between two endpoints. And the main reason for a VPN is to encrypt your data so that it is now no longer subject to man-in-the-middle or eavesdropping or modification attacks. So this is a layer of security that you're adding when you're connecting to the internet using an encrypted channel, which would prevent you from getting hacked or your data being compromised by hackers. So as you can see here, and if you remember the previous slides that we have seen, the hacker was able to copy the data very easily. Now that it is an encrypted channel, even if the hacker tries to eavesdrop and capture that data, it will be formatted in such a way that they would not be able to make sense out of it. Now the attacker or the hacker will have to try to decrypt the data. So that's another attack that they'll have to execute to find out the encryption key, decrypt the data, and then look at what the data was. Then we come across botnet. Now, let's understand what bots are. Bots are nothing but the softwares that can be installed on vulnerable machines that would allow the hacker to send commands to the infected machines to generate some traffic or to do what the command tells them to do. So most of the botnets are used for distributed denial of service attack. If you remember the DOS and DDoS that were discussed a while back, this is where we tie up with how they are executed. So a bot master or a hacker, let's call them a hacker, would try to identify vulnerable devices across the internet and try to install the bot onto those devices. The bot essentially is a software that would revert back to the bot master and advertise their availability whenever they have been powered on. A collection of such infected devices would essentially be called a botnet. When there are enough number of machines that the attacker feels are good enough to launch that attack on the targeted servers, the hacker will then initiate those devices, send the commands through the bot master to the bots, and the bots would then generate that kind of traffic with whatever they have been configured for, and then attack the targeted server. Now, this is also done to mask the identity of the hacker. Since the attack is being generated through the botnet, the IP addresses of the botnet computers would be reported to the targeted server, not the actual hacker's IP address. So to figure out who the attacker was would be very much difficult depending on the size of the botnet. So this, you can see, is the attack that has been carried over the victims, and the malicious traffic has been generated through the botnet, and the victims have been targeted through that. So as said, once that traffic has been done to forensically investigate at the victim's end, they would find the IP addresses of the botnet and not the attacker.